three particles are connected by light in extensible strings as shown. We want to find the tension in each string. If we consider T1, this string is lifting the combined system. So it's lifting a combined weight of 6 kilograms. Note the other two strings are defined to be light and therefore add no weight to the system that the first tension is lifting. The combined weight is therefore 6G, and it's being lifted by the first string with a tension T1. The system is accelerating upwards at 0.5 meters per second squared. Using F equals ma, the resultant force on this system is T1 take away the weight, and that's equal to the mass times the acceleration. So T1 is 6 times the acceleration, which we know is 0.5, plus 6 times g, which we'll take to be 9.8. And therefore T1 is equal to 61.8 newtons. If we now consider T2, this is lifting just two of the objects. So consider these as combined. T2 is lifting these two objects. The weight 5G is acting downwards. The system is accelerating upwards at 0.5 meters per second squared. We can now use F equals ma. The resultant force here is T2 take away 5G, and this equals the mass times the acceleration. So T2 is going to be equal to 5 times the 0.5, add 5G, and with G equal to 9.8, this calculates to 51.5 newtons. Finally, consider the third string. This just lifts one object, the 3 kilogram one. So we have tension 3 acting upwards and 3G acting downwards. The acceleration 0.5 meters per second squared is upwards. Using F equals ma, the resultant force acting here is the T3 take away the weight, and this must be equal to the mass times the acceleration. So T3 is going to be 3 times the 0.5, add 3G, and this calculates to give us that T3 is 30.9 newtons. We're often asked in mechanics questions what's meant by light and inextensible, and how these assumptions have been used in doing our question. Light we already discussed. The strings add no weight to the system. Real strings, however, are also extensible. If we put a greater weight on a string, it will stretch to a greater extent. These strings, being inextensible, remain the same length all of the time, and this means that our three objects accelerate upwards at the same rate, and not only that, at any time they will be travelling with the same speed. This would not be the case in practice, as when we first start pulling, the strings would stretch according to the weight on them, and therefore the acceleration would not be exactly the same at all times. So in practice, inextensible in our questions means that the objects accelerate at the same rate.